Okay, for this question, fx is equal to 5 minus x minus 2 in brackets to the square for x belonging to the set of real numbers where k is less or equal to x less or equal to 6. And now we need for this function to state the smallest value of k for which f has an inverse. Now let's look at the first part of the question. If a has an inverse, I mean this function has an inverse. This function we're talking about is y is equal to 5 minus x minus 2 to the square. Now we can clearly see that x squared here is negative coefficient, so our curve is going to look something like this, inverted like this. Okay, and here is the maximum point of this curve. What is that point? X minus 2 is equal to 0, therefore x is going to be equal to 2. And what about here? Where does this curve end? Should be ending somewhere there. Alright, but at the same time, what's the value of y? So the value of y is 5. So I've got 5 here. So this is the point 2,5. That's the maximum point on this curve. That's where the vertex is. Now we need to find, state the smallest value for which this curve has an inverse. If it has an inverse, then it's got to be a one-to-one function like this. Okay, and so it's got to be a one-to-one function for fx to have an inverse. That's what we need to understand. Now therefore the value of k here is 2, so the smallest value of k will be 2. For this value of x, I mean for this value of k rather, alright, we need to find an expression for f inverse of x. Now first of all, let us state again, fx is equal to 5 minus x minus 2 to the square. If you want to find the inverse of this function, it's very easy. What you need to do is just call this y is equal to 5 minus x minus 2 to the square. We're going to rearrange to make x the subject formula. So I can say x minus 2 to the square on the other side is equal to 5 minus y. Therefore, x minus 2 is equal to plus or minus the root of 5 minus y. That means x is equal to 2 plus or minus the root of 5 minus y. What are we saying, in other words, is that fx, f inverse of x, I would rather say, is equal to 2. There's a plus and a minus. Okay, we're moving from in the positive direction here. So therefore, I'm going to say plus. I'm not going to take minus. So reject that 1 into 5 minus x. Now that's the inverse. And then we need to state the domain and the range of f inverse of x. Now, what do we need to do? How do we do this? Okay, we need to understand that the domain of the inverse. Okay, we need to find the domain of the inverse. Okay, domain of f inverse is equal to range of f. Okay, so what was the range of f? The range of f started from here and went all the way down here. So it started from 5 and then it went all the way down here. This is what we didn't find in the beginning, right? So I need to find this point here. So what is this point basically? Now remember that here we got from k to 6, okay, from 2 to 6. So if you substitute 6 in here in the equation, let's do that. So we're going to get y is equal to 5 minus x minus 6 to the square, which is then minus 11. So this becomes minus 11. That's the range. This range for fx is the domain for f inverse of x. Therefore, I'm going to say domain, okay, of f inverse is negative 11, move all the way up to 5, but that's the domain now. Okay, so less or equal to x, less or equal to 5. We are done. Now we need to state the range of f inverse. Remember, it's the same thing that we mentioned before, that the range of f inverse, okay, is the domain, is the same as the domain, okay, of f. Now what was the domain of f? The domain of f was basically from 2 to 6. Here we have the domain, okay, from 2 to 6. Okay, that's our domain. Therefore, the range of f inverse, okay, is 2, okay, less or equal to the domain, okay, I mean the range, so rather the domain, I would say range, so the range rather, because we're looking for the range, not the domain, the range, but the domain is equal to the range. We know the domain is from 2 to 6, so here we go, less or equal to 6. Here is how you're going to find the range and domain of the inverse of a function, basically quadratic function. All right, I hope this helps. Take care.